not coming off around here.
Did you guys play railroad anymore today? Did the lads like the new cut?
So in the last episode, I wanted to try and resolve my issue with the USB host shield. When I last discussed my issue with the host shield, I stated that it didn't detect when a USB device was attached. But I also pointed out that the host shield library code was able to communicate via its SPI port with the shield's MAX 3421E USB host chip. Okay, so the chip, which is, I don't see what I got here. Oh, I got pointers now. It's this guy right here. Okay, that's basically the heavy lifter on this entire host shield. Did I bump that? Sorry about that. So anyway, my assumption at the start of this investigation is that something's not right with that chip, the MAX 3421E chip, its ability to detect an attachment. So that's the focus of my initial checks. So because of the PS4 controller example initially worked, I asked myself, did anything change? And in fact, something pretty significant did. In the initial test that worked was done with the different PS4 controller that was done with this PS4 controller, which is newer and fully charged because I generally recharge it every time that I use it. So it's on charge. If I've been using it at all, it gets plugged back in and it's recharged. But for those who don't know, these PS4 controllers don't need to be plugged into the USB port. They have a Bluetooth connection. This one is the one that I used in the second trial, and this is the one that did not work. And with this one, because it's an older controller, I seldom use it. It's generally just sitting on my desk, and it's not plugged in. It's typically not plugged in. Additionally, when I originally tested with this PS4 controller, I used this cable. When I did it the second time, I used this cable, which I pulled out of a junk box, and I'm really unsure what the condition of that cable is. So I've got some variables here that I need to get straightened out. And as far as the battery in the controller, I had also considered the possibility that the host shield was actually trying to charge it, and it may have caused a problem because of that. So what I'm going to do is I'm going to repeat the test, the second trial, only instead of using this, we're just going to go away, we're just going to use this guy, which was what was used in the original trial. So I've got the PS4 example loaded into the Arduino, and I have the host shield mounted. And at this point, I'll just give you a little foreshadowing. I've already done a number of checks of this host shield, and I also received my new host shield, so I could switch out if I wanted to, but I'm still curious about what's going on here. And so let me proceed with this recheck using this controller, and then I'll go into explaining the things that I've detected about this host shield that I find just a little bit hinky. Okay? So I have everything ready now to rerun the PS4 controller example for the USB host shield. And it's going to, initially, I'm going to power up the Arduino. I say, doing things wrong here. No, initially I'm going to connect the USB. Holy smokes. I'll get this connected. Get that out of the way. Plug that guy in there. Okay. So now just power that. So you need to have additional power because this thing draws so much current. So it doesn't work too well without that. Port, COM4, tools, board. Okay, now it claims it started here on the serial monitor. So if I connect the PS4 controller using the original cable and the original PS4. Make sure I have that right. We're going to find out whether or not. Should see some activity here if it actually gets connected. Oh, nothing. Nothing at all. Okay, what I'm doing right now is I'm wiggling this connector, and the reason why I'm doing that is for a reason I'll show you in a moment. But obviously it's not. That's still not working. The chip, the 3421E USB host chip here, is not seeing a connection. So let's take some further examination of this board, and I'll share some of the things that I've found when I did a careful survey of the entire board. Here's a picture of the USB host shield circuits. And what I'd like to draw your attention to are these two now marked yellow conducting traces that are for the D- and D+ signals that are coming in on the USB connector at the top of the image. And if you take a look at this region here, I'll show you this close-up of the connector there. And where the arrow is now pointing, you can see that contact, unlike the ones to the left of it and the one to the right, is not soldered. It's just maybe making contact. It's kind of a hard thing to tell. I'd have to check it with my volt ohm meter, but I think that that's a problem. I imagine that it's a mistake in the manufacturing, and it's certainly not something that is desired to have that unsoldered connector like that. But why I was wiggling the connector earlier was to see if by wiggling the USB connector, that contact would better make between the two conductors and actually cause the 3421E host chip to be able to actually detect the connection, but it didn't help. So I suspect that that's actually making, it's actually conducting, but I'm still upset that that's not soldered, and it should have been. In keeping with my focus on the MAX 3421E's inability to detect an attached device, I noticed something in the image here that didn't seem correct. Returning to the previous image of the host shield circuit board, these are two 22 ohm resistors. Each one is a series resistance, one on either of the two USB communication lines. Earlier, I read through the 3421E's electrical specification. Maximum specified 33 ohm resistors for the D+ and D- communication signals. So the 22 ohm resistors are not correct per the specification. This is the second issue that I have with the board, although it doesn't strike me as a significant issue, so I'm going to continue to investigate further. I suspect at this point that the electrical explanation for the MAX 3421E's inability to detect an attached device is related somehow to voltages. Since we're talking about the voltages of the D+ and D- lines between a device and a host, I'd like to briefly discuss what the D- and D+ signals are expected to be at the point at which they become connected, so that there's an existing signal that the host shield's chip can see and be able to detect as that the device is actually attached. The USB state named SE0 is the disconnect state. Whenever any device is powered by the host 5 volts, this 5 volts is going over to here, the device itself then pulls either D+ or D- high to 3.3 volts with a 1.5 ohm resistor, which should overpower the host shields internal 15K ohm pull-up resistors. This is the J state, and it's also the transmission line's idle state. So at this point of the connection, the host shield is going to see what is defined as the idle state. Depending on which of either the D plus or D minus is pulled high, specifies to the host over here whether the transmission is a low or high speed transmission. One that moved up from the original USB 1.0 to the later versions, they added higher speed transmission lines through them. So during the connect output state of the attached device, the idle state is maintained. If the host then detects, this guy's going to detect that idle state on the D plus, D minus lines, it responds with a reset state by driving both the D plus and D minus low for 10 milliseconds. That state resets the device that's attached. And then once it's been reset, then the host can request the device's configuration, and then it knows that both the device is attached and what kind of device is attached. So to start, I checked with the USB technical specification to identify the intended D plus and D minus input signals voltage levels. And I'm showing this in this image, a copy of that specification. It defines the static low is 0.3 volts and the static high is between 2.8 and 3.6 volts. So the nominal high voltage then is 3.2 volts, somewhere in that range. The image you're looking at right now shows at the very top the voltages that are expected per the USB specification for a low and a high voltage. The little table just below that shows what the USB standard defines for a connected device to be showing an initial state when it's connected between the D plus and D minus signals. And you can see that if they're both low, that it's an SE0 state, which is disconnected. And it would be like that because the chip on the shield has pull down resistors that make sure that those lines stay low. Now, what I measured is at the very bottom of the screen. I measured initially with it disconnected, and I measured 0 volts for D minus and 0 volts for D plus. And then I connected the controller and measured 0 volts for D minus and only 0.06 volts for the D plus, which is essentially zero. I mean, it's if you look back, anything up to 0.3 volts DC is considered low. So it's still low. I can't easily explain why that would happen, but it does make me think right off the top of my head that what I may have here is either a solder ball or a whisker bridge between either the two traces or the two pins on the connector itself. Using the spare host shield, the new one that I just purchased, I want to measure the unpowered resistance between the D plus and D minus traces on the defective one, and also on the replacement host shield, and compare them to see if there's any kind of a short between the two lines coming in from the connector on this host shield. So let me do that quick and see if I can learn anything about solder balls or any other kind of crazy short condition. I'll measure this one, and it's reading about 2 meg. Okay, I'm going to go over to this one to get out of the way. To that. No, okay, about 2 meg. So there's no short that's causing there's no short causing the voltage to be, as I'd shown, the low. So I'm going to move on with my investigation to see if I can locate some other cause. Okay, so as if things weren't confusing enough, I've just discovered I was setting up my scope and I was going to just take a look at the actual voltages with the scope trace on the D plus and D minus, just to make sure that I wasn't looking at some kind of an anomaly, because the the transmission format on the differential signal of the two D plus and D minus signals is what's called NRZL, or not return to zero. And that kind of a format for transmission is it's possible to read some strange voltages with a voltmeter, so because it's not really a DC signal, it's an AC signal. So what I've done was set up my scope, and then I was going to just take a scope reading. So then the next thing I did, and I'll reenact it for you here because I want you to see this. I went, now recall, this host shield was not working. It was absolutely not working, I can guarantee that. And so now I go to bring up an Arduino thing here, and let's just go to, let's call it a new sketch so I can get rid of that. And then I'm going to open up the serial monitor so I can see data coming back. And then, so we have to go here and tell it what kind of board. So it's it's an Arduino Uno. And then I have to tell it what port as soon as I connect that. So I'm going to connect it now to the USB port. And I'm not even using external power. That's just the USB port. And then I'm going to define the port. Oops, first thing I have to do is back to this now, go to Tools, Port, COM4. And this looks kind of junky because the baud rate's wrong. Oh, there it goes. Oh, that's right. So it shows that it started. And look at this. You see that? That's data coming back from the PS4 controller. So to be honest with you, I guess it's working, but why would it work now and it didn't work before? And isn't that odd? I don't know that. I can't explain that, but for some reason the chip is happy now. I was about to, my whole conclusion at the end of my previous discussion was that the chip had been damaged somehow, but it's evidently working fine. So I just, oh gosh, I guess it's going to be hit and miss. So given this, let's just move forward and we'll just deal with it. And if it's going to be intermittent, then it will be. We'll find out. Disconnect that. I'm sorry for all this mess, but you just never know what you're going to get into when you start one of these electronic projects. I'm going to run with what I've got right now, and I still do have the spare. And I can always go back and, if it finally totally dies hard, I can go back and recheck the host shield that goes bad and see if there's some other explanation for it. But I gotta say, this puzzles me. I think the video length now is probably appropriate for release of what I've accomplished so far in the pursuit of trying to run JMRI via a Bluetooth connection to the ProCab. This you've seen before is the 20x4 display module. It's an LCD display module. And why I'm showing it is because I've decided that because this particular video now has gotten as long as it did, that I'm going to just release this one, and in the very next one I'm going to start working on the driver for being able to use the USB host shield with the NCE USB interface, which will complete, hopefully, it will complete the entire communications link from the ProCab through the power panel, through the USB interface, through the host shield, through the Bluetooth, and finally get to my broken laptop. So this is quite circuitous, but I don't know. It's been kind of an interesting path, and it has raised some interesting issues, and actually has exposed some interesting information about the various different communication technologies. So what I expect to see here when I go on and work with the software is a message that will say, that this guy detected at an attached device. And that's what I'm shooting for, because it will be my own driver and not somebody's example. And I'm going to have to communicate a bit about the library software that I'm using to be able to do that. So there'll be more discussion, but it'll be primarily about software. I'd like to thank everyone who's watched my videos or has watched this video in particular, and I do appreciate that you've taken your time to share with me this journey that I'm on right now with this particular project. It's, as I said, it's been a little bit difficult. And if you wouldn't mind, if there's anything in this video that you thought was interesting to you, please leave a like. And if you're new or haven't yet subscribed, if you'd like to see how all of this ends, please subscribe. Again, thank you so much. I do appreciate everyone's time to share this event with me.